Sam.
So that means in in southern hemisphere right now it's summer?
Yes, exactly.
I did not know that. That's pretty cool.
Yeah, thank you for the video. Okay. So anyway, so given what we just started with our Kahoot quiz to get our brains thinking about what we read yesterday, right? And we saw the video to again activate some of our knowledge. Yes.
February is winter, right?
Mm-hmm.
Well, would they still, since it's summer for them right now, would they still say it's February, but their season's different? So to them, February is totally different.
For them, February would be.
Would Christmas be in summer for them, or would they also still have a winter?
It's very good.
Would Christmas be in summer for them?
Yep. Yep. Exactly.
But it's a snows time over here.
And well, it's snow.
To us.
That's how we think of it in the northern hemisphere. Excellent question. So what time of year right now is it?
So when they think of it in our way, they think it's totally weird.
Yeah, it's backward. So right now in the southern hemisphere, it's February, but what season is it?
Summer.
But very good. It is, and it's still the same month. So for them, February is summer. Yeah?
But also
Pretty
when the
weird.
earth is tilting like this way, but not by northern southern but by west and east, doesn't one side the other side of the earth can be a day ahead or a day behind? Or
So that's not about seasons.
no, I know, but isn't that by days?
Yeah, by 24-hour periods, because it takes 24 hours, right, for the Earth to complete one rotation. Very good, Avery. Okay, you're going to do very well. So let me set the purpose here. I know we started with our quiz and watched our video to activate our background knowledge and get us ready for this. And I know this doesn't show up very well on the video, so I'm going to have to read this. Can you guys read it okay?
Mm-hmm.
Our purpose, we're going to do a couple of important things today. Number one, you're going to work in your groups together to create a graphic model, which is basically just a drawing or a diagram that's going to show why the Earth has seasons. So your diagram is going to explain that, help people understand what causes Earth's seasons. Okay, and then also in your groups, after you do the diagram, you are going to write a science argument. Now we've talked a little bit about science argument, but I've written some prompts up here to help you remember what the different components are of a science argument. And again, you're explaining why the Earth has seasons. You can think of these two activities both as answering the question, why does the Earth have seasons? So that's our main goal today, is to answer this question. So your claim is going to say something like, the Earth has seasons because, and then you're going to finish that sentence. Or you're going to say the cause of Earth's seasons is, right? You're going to support it with scientific explanation or facts. In other science activities we've done, we've been able to use our own data that we've collected, right? When we've done little experiments in class, like when we worked with plants and we were measuring plant growth. But in this case, we were not really able to collect evidence for this, or it would be very complicated. You're going to need reasoning that uses scientific principles that explains why the evidence supports the claim that you've made. Okay? And then, for challenge students who are ready for this, everybody is not required to do number 4, but you should think about it while we're working with our globes and our flashlights. A rebuttal or a possible counterclaim that's going to explain why other explanations are not supported by the evidence or not as good as the argument that you're making, okay? The claim that you're making. All right, so let's get started. So the first thing we're going to do, I'm going to explain a little bit about this. I'm going to set it up, and then you guys get to work in your groups. We have globes and flashlights for everyone so that you guys can explore this relationship on your own between the earth and the sun and try to make sense of what's going on. Okay? So actually, could I get a volunteer to help me with this part? Because I think I need another pair of hands. Would you like to help me?
Sure.
Avery? Okay, good. All right. Let's have you be. Actually, maybe you're going to be the sun. Why don't you be the sun? So turn that flashlight on. Can you turn out some of these lights? Okay. Now, first of all, if you're the sun, are you going to be moving around me, or am I going to be moving around you?
You're gonna be moving around me.
Say that again.
You're gonna be moving around me.
Good. Okay, so let's get, okay, that's good. So, you are the center of my solar system. Okay? Now, we know that the sun, or excuse me, the earth is rotating constantly, right? Every day it goes around one time. So it's spinning on its axis as it's traveling around the sun. And you're going to have to turn around backwards for me.
The sun does not turn.
Yeah. Well, you have to pretend that you're shining out from all different directions. Now, notice what I'm doing here. Who picked up from the reading or the video why I'm being very careful about the way that I'm holding the globe? Do you see anything that I'm doing here with the globe?
Well, I'm seeing, like, when it's over here, like, this area has more light, and when it's over here, like, this area.
Oh, very good. Okay.
Because the way it's tilted.
Because the way it's tilted. So what am I doing with the tilt? Let me go around again and pay very careful attention and see if you can see what I'm doing as I go around. This is kind of hard. I don't know if it all shows on the video because we have a small range here. Okay, so like do you remember them saying anything about this in the video?
I don't know.
Okay.
Wait, is that the thing?
That is the international date line. That has to do with days, counting days, not really seasons. Okay.
So right here would be like summer for the northern part?
Very good. This is summer for the northern, what do you call it? Hemisphere. Very good.
Hey, California.
Nice science terminology. Okay. So what I'm going to do now that we've started, before I answer all the questions, because we don't want to do that, that would take all the fun out of it, you guys are going to work in your groups and explore working with the flashlight and globe real quickly. So work with your partner. And then after you guys do this is when we're going to make our drawing that explains what you've discovered by working with the globes and the flashlights, okay?
Wait,
We'll make it sharp.
Since it's tilted, doesn't it like the earth makes it so the light kind of goes to the other side of the equator?
No, look at, as the earth goes around, the tilt never changes. It stays the same relationship. See how, look at my hands tilted. It stays tilted the same way. That's what she was walking around showing.
Yeah,
Yeah.
like if it goes to this side, this, like, the sun doesn't spin, but when the earth does it, this side, it would be
That's right.
above.
Very good.
Point.
So now what you want to try to do is figure out, by using the globe and the flashlight, explore how you're going, think about how you're going to put that on a chart, on a drawing, so that it makes sense and you can explain it to somebody else. You guys can still play with that if you need to. So think it like,
We could totally draw the solar system here, like the sun, and then draw the earth orbiting around it, and then maybe draw a picture, like check it out. What if we drew the sun right here, like maybe this big, and then the orbit of the earth out here, right? Like this big. Well, out here, we'll put a line drawn to the orbit and draw a picture of the way the Earth is set up there, the tilt. And then we'll draw the tilt here and show that it's kind of the same way, but in different relationship to the sun.
So actually, before we get too far, let me show you something. I made a checklist that goes with your groups. You were supposed to get this already. And this shows all the different things that you need to have on your diagram. Now you've already got your materials here. So checklist for what to include in your model. You need to make sure you have a sun. What else do you see there, Avery?
What?
Oh, I'm saying this checklist helps you make sure you have everything you need on your drawing to get full credit.
So we'd have one diagram representing summer, one winter, one autumn, and one spring.
Yeah, kind of like I was just saying, we could have one in each corner showing the relative position from the sun to the Earth, and then show the position of the Earth as it passes that part of the orbit. But I don't think I'm going to get extra credit because I don't know what these are.
Which ones?
Equinox, solstices. I don't know.
Oh, the dates.
Yeah.
Oh, those were on in your reading, and I will provide your reading. This was from yesterday.
I was absent yesterday.
I'm sure you brought your notes from yesterday, so the dates are on here.
Me too, I was absent.
Here.
I think everyone was absent. Even her.
Okay.
Even puppy dogs. Even you.
So are we starting on this now?
Yes. I'm trying to figure out video-wise if I should go ahead and just sketch something out in a couple of minutes,
Okay.
and
So,
then
like, you know how, like, we have, like, summer break? Do they have winter break? Like, the whole winter off?
so for them, would it be a winter break or would it be a summer break?
Well, for us, it's called summer break. It's like the whole summer off on some of it. And for them, would the big break be winter break? Would they call it that?
I don't know. I guess it depends how they run their schools. But right now, let's say they're on break right now at this time of year, in February. What season is it in the Southern Hemisphere?
The southern? Summer.
So would it be called winter break or summer break?
Oh, right now?
Yeah.
I was talking about when it's summer here.
Oh, well, do you think they have their school breaks the same time of year we have them?
I guess.
I don't know. We'd have to, I guess, find that out. We could
I-
research that later. I don't know.
I think they would, wouldn't they? No. No, actually, I don't think. I think they have, like, they both have it in summer.
Probably makes sense that if the Southern
Because the way they run.
Hemisphere is experiencing different weather at different times of year, that they're going to make their school calendars and their jobs and whatever makes sense for the weather they're having, right?
I have an idea. You know how you do the video chat with other countries sometimes? Do you ever do one of someone in the Southern Hemisphere?
Oh.
Because if they're in school at the same time you are, that would tell you that they're not out of school during winter, right? Have you done one of those lately or no?
We have.
What country was it? Oh, I remember that.
Oh, wait, no.
Wasn't it Africa?
Yeah, but is that. Oh, it was right here at the equator. I'm not sure if it was under or above. It was Kenya or something. Can't pronounce it. But yeah, it is.
Kenya is just above, isn't it? Or wait.
All right.
Maybe some under. I don't know where they were.
Okay.
But it was nighttime there.
So let
and
me
the
go
teacher was
on.
talking to us.
Sorry about that. Let me go on and just model a little bit more of the Earth-Sun relationship for you guys to help explain the seasons a little bit better. Is this globe in the way
No.
of that?
A little bit.
I'm saying because I'm not doing the same type of chart that you're doing because I'm not gonna show, the earth in 4 positions. But I am giving you an idea. I think this might be in the way. Oops. Okay, so what I'm doing is I've used my 360-degree protractor, and what was the tilt of the Earth's axis? Do you remember what it said? We talked about, so the Earth is it straight?
No.
Is it tilted? Does
Yeah,
anybody
tilted.
remember the
It's-
number?
No.
Was it 25?
It's close.
25 point something or
Close.
23?
Very good. About 23.5 degrees.
Oh.
So what I've done is I've got this about straight up and down, right? Here's 0, so I marked it at 23.5 degrees. And I came over here, 10, 23.5 degrees. And I'm going to mark my axis. And actually what I need is a
Equator?
well, no, because the equator, as the Earth is rotating, let me get this tilted the same way. Where's the equator?
Here.
So the equator looks like it goes
Mm-hmm.
perpendicular to the axis. Perpendicular, would you say? That's like a perfect X or a T, right? Perpendicular to the equator. So I'm actually not making the equator right now. I'm making imaginary dotted line to show us the tilt. The angle of tilt is 23.5 degrees. Okay? From straight up and down. That is if the Earth the axis were positioned straight up and down or perpendicular to the plane of orbit as it's going around like this. But we know it's not perpendicular to the plane of orbit, right? Okay. So then we can add our equator on here. Which looks like it'll be about like that. Equator. Well, it's a little bit high, sorry. But you guys have the idea. Now, where did my pens go? Now let me show you this. The sunlight comes across, solar radiation travels through space. I'm going to need a darker pen for it to show up. Can somebody grab me a red pen? This one's not going to show up on the behind you. Right behind you. Orange pen worked. All right. So units of solar radiation, or in a way, like a portion of it, they're coming straight out from the sun in all directions, right? And so when you have the portion that's hitting the Earth straight on, it's very concentrated or direct, right? It's hitting, would you say the sunlight and the sun's heat is hitting the Earth right there is fairly intense or not intense?
Intense.
Intense. Very good. I would agree. Now, we come down here, and we're going to use a portion of Earth's solar radiation that's the same width as the one we just did, right? I'm using the two sides of this ruler to make sure they're the same. Now, look at what's happening here. This same portion, so to speak, of solar radiation is traveling through space, and by the time it gets over here, instead of hitting a portion of the Earth that's that big, look how much bigger this is. That same amount of solar energy is spread out over a much bigger area.
So that means when this is the south, southern is in the northern.
Yes. So what season right now is it in the southern hemisphere? Let me say that louder.
Winter.
Winter. I'm just trying to get on the tape. Very good. Winter. And which one is having summer right now?
Northern.
Northern. Yeah. Do you see? So this is the same amount of solar radiation, the same unit, so to speak, spread out over a larger area. So is the sunlight that's hitting here more intense or less intense than this part?
It's less.
Less intense. It's
Less
less
a bigger area.
less concentrated.
Like
Less.
it would be a bigger area for it to just like to heat up. And
Very good. So you could also speak of it in terms of not only intensity or concentration, but density. It's less dense here. It's spread out over a bigger area. And if you explore with your globe, which we were trying to do, if you're very careful and you hold, sorry.
the sun
Wait,
would do
why is
that.
it? Why is it doing that? Sorry, Avery. So, if you keep it parallel to the Earth, sorry, let me do it like this. Is that better? If you keep it parallel, it's hard to do with a flashlight and a globe, but you can tell if you're keeping your flashlight. In other words, you're not tipping it like this, but you're moving it up and down like this. You can see how you have a very dense area of solar radiation, and as you move down, what happens to your what was your circle of light?
Comes over.
Yeah, it's stretching out.
Wait,
It's covering
if
a
that was
bigger
on s-
area.
like the sun would be the sun would be right here. It would be summer in the southern,
Yes.
and then this would be spring. No.
Could be
Spring?
spring or depending on which way, because I'm not sure which way. So it could be spring or it could be.
Well, wait. I think this is actually autumn.
Okay.
I'm not completely sure. I think it is. This would be winter for the southern. And this, I believe, is spring.
Okay. Yeah, because you're going in order of the calendar. Good. Very good. Sounds like you've got it. All right. Go ahead and start on your diagram. If you guys have questions, I'll help you. I'll clarify.